Okay, so how do we calculate it? Let's get into how we calculate it a little bit more in a little bit more detail. Let's suppose that we're not given the percent changes, but rather we're given the absolute changes, right? We're told that say price goes from $1 to $2, and quantity demand goes from 100 to 60, right? So we're not given the percent changes. We're given the absolute changes. If that's the case, then we need to use this formula to calculate those. Now, you may have learned how to calculate a percent change in some other class, maybe finance or some other math class. And in economics with elasticities, we do it a little bit differently. So let me go to my doc cam, so we can talk about this a little bit more. So you may have learned that a percent change, which I will often denote as a percent triangle. So that's the letter, the Greek letter delta. It means change, right? Percent change, you may have learned to calculate it like this, right? So you take the new value, let's say x2, and you subtract it from it the original value, x1, and you divide it by the original value, x1, and multiply by 100 to get it into percent terms, right? So that's how you may have learned to calculate percent change. Well, with elasticities, we do it a little bit differently. Rather than dividing by the original value, we actually, for elasticities, when calculating these percent changes, we divide by the average of the two values. All right, so rather than dividing by the original value, we actually divide by the average. So this is actually how we're going to calculate percent changes for elasticities. So the top stays the same, no change there, right? What's the absolute difference between the new value and the old value? And then we're comparing it to, instead of comparing the change to the original value, we're comparing the change to the average of the two values. Okay, so there's the average there on the bottom, right? That's the average. So that's what you're seeing here, right? And there's a good reason why we do that as economists with elasticities, but I'm not going to go into it because it takes a little time to explain. But if you're interested, email me and I'll be happy to explain it to you. Okay, so here's a numerical example involving the price elasticity of demand for movie tickets. And so here again, we're not given the percent changes; we're given absolute changes. Okay, so we're going to need to use this the new formula we just saw. So the nationwide price of movie tickets increased from $7.84 per ticket to $8.08 per ticket. And in response to that price change, the quantity of movie tickets purchased, in other words, the quantity demanded, decreased from 1.34 billion tickets to 1.26 billion tickets. Now, ceteris paribus, assuming everything else is equal, what is the price elasticity of demand? Okay, so I encourage you to pause the video and try to calculate this for yourself. Okay, so using the formula we just learned, we are going to calculate the percent change in quantity demanded, which is on the left side there. So the difference in quantity, the absolute difference in quantity divided by the average quantity. And then we're going to divide that by the percent change in price. So the absolute change in price divided by the average price. And ignoring the negative sign, you should have gotten negative, ignoring the negative sign, you should have gotten 2.04. Now, again, what does this mean? How do we interpret that? It basically means that given a 1% increase in price, there would be a 2.04% decrease in the quantity of movie tickets purchased or the quantity of movie tickets demanded.